Welcome back to another exciting class, and today we're going to be continuing on the concept of scientific notation, but we're going to use it with a thing called significant figures, so let's get into it. First of all, significant figures, when you have a number and you're asked to find how many significant figures there are, you count how many digits there are from left to right, but you start at the first number that's not a zero, so you can't start with a zero. And if you have zeros at the end of the number, they are not counted unless they're whole numbers, and then we'll talk about that. That's a special case. So here's an example. How many significant figures does this particular number have? Well, we start counting from the first number that's not zero. There it is, the 3. So there is 1, 2, 3, 4, 5. So we have 5 significant figures. How many significant figures does this number have? Well, you can't start counting with zero, so ignore, ignore, ignore. Aha, 1, 2. So there are only 2 significant figures for that particular number. What about this one? When it's written in scientific notation, you just ignore the times 10 to the power of 2. Forget it. We're just focusing on the 3.21. So we start counting from the first number that's not a zero. There it is, 3. So there's 1 number, 2 numbers, 3 numbers. So there are 3 significant figures. Now, this is the trick one that I was talking about here. If it's a whole number, you start at the first number that's not a zero and you go 1, 2, 3. Well, they're all zeros, so we ignore them. So there are 3 significant figures normally. But when it's a whole number, sometimes we can count these zeros and we might decide to go 1, 2, 3, 4 and then stop. Or we might decide to go 1, 2, 3, 4 and 5 and then stop. Or 1, 2, 3, 4, 5 and 6 and then stop. So any one of those answers is correct. It's a bit weird with whole numbers, and it depends on the question as to how many significant figures you're going to count, but generally speaking we ignore the zeros. Righto, let's try some examples. So state the number of significant figures here for 325,000. So we go, oh, there's the first number, the second number, the third number. This is a whole number, so there could be 3 significant figures, or 4, or 5, or 6. It's one of those weird ones. Let's go to the next one. Remember, we don't count any numbers when we're starting if they're zeros. So ignore, 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 ignore. Aha, 1, 2, 3, 4, 5. So there are 5 significant figures. What about this one? Aha, there's a 1 at the beginning and a 1 at the end, so it doesn't matter if there's zeros in between. There is 1, 2, 3, 4, 5, 6 significant figures. Ignore the scientific notation. We're just looking at the 4.22. How many significant figures? That's not a zero, so 1, 2, 3. 3 significant figures. Now, this question says to write these numbers using scientific notation and 3 significant figures. So let's put it in scientific notation first. Now remember, with scientific notation, the decimal point is normally for a whole number at the end. And from the last exercise, we learnt that we want the decimal point to be after the first number that's not a zero. And there are 1, 2, 3, 4, 5, 6 numbers between those 2 decimal points that I've just drawn in there. So for this particular question, it's 2.344, we don't worry about putting these zeros on the end, times 10 to the power of 6, because the decimal point was there and I've moved it 6 places. Now that's the answer in scientific notation. Now I need to convert it into 3 significant figures. Remember, we don't worry about this part. How many significant figures do I have here? 1, 2, 3, 4. I only want 3. So I'm going to ignore the last digit there. But you've got to be careful. If that was a 5, 6, 7, 8 or 9, I'd have to round up. But in this case, I don't have to round up. So the answer is 2.34 times 10 to the power of 6 if I write it in scientific notation with only 3 significant figures. Let's try this again. Now we can see where the decimal point is originally. Here it is. We want to put it after the first number that's not a zero. That's there. And there are 1, 2, 3, 4 numbers in between. Remember, this is a very small number, 0 points, so I'm going to have a negative power. So it'll be 1.92763 times 10 to the power of negative 4, because I had to move the decimal 4 places. Now that's the answer in scientific notation. I now need to make sure I've only got 3 significant figures. So there's the first figure, there's the second figure, there's the third figure. I'm going to stop there, but because that number there is a 7, 1.92 has to bump up and become 1.93. So the answer is 1.93 times 10 to the power of negative 4 if I want to write this in scientific notation, rounding it to only 3 significant figures. Now, with a question like this, just plug it into your calculator. It says use your calculator to evaluate the following, leaving your answers in scientific notation correct to 4 significant figures. So you just plug that into your calculator as it is written. And that's the answer that you'll get. Now to 4 significant figures, we need to count our 4 figures. So 1, 2, 3, 4. I want to stop there. Because my next digit is 5 or greater, 1.555 needs to bump up to 1.556, and it'll be times 10 to the power of 11. So there is my answer in scientific notation using only 4 significant figures. Again, just plug that into your calculator as it's written, and when you do, you'll get that answer there. Now we need to convert that into scientific notation first. So, where is my decimal? Originally it's here. I want to move it to there, so I'm moving it 2 numbers worth, or 2 positions. So it'll be 8.144257748 times 10 to the negative 2, because remember, any numbers that start with 0 point are going to have a negative power when it's in scientific notation. Now, when I wrote this, I could have gone like this, 8.144257748 times 10 to the power of negative 2, but I've gone straight to looking at only the first 4 digits. The next one is a 2, so it's not going to round up. So you can see why the answer is 8.144 times 10 to the power of minus 2. That's 4 significant figures using scientific notation. Well, that's the end of the theory. Enjoy the questions because they are indeed a rewarding experience. Bye for now.